Let's discuss how to calculate voltage drop for incandescent light fixtures on a branch circuit. Imagine you have 15 incandescent light fixtures connected on the same branch circuit. They are equally spaced 10 feet apart, with the first fixture being 10 feet from the power source. Therefore, the last fixture is 150 feet from the source. Each light fixture is rated at 100 watts and 120 volts. The maximum ambient temperature is 75 degrees Celsius, and the wiring used is number 12 American wire gauge copper. We can calculate the voltage drop for each light using Ohm's law, which states that voltage drop, expressed in volts, equals current, expressed in amps, times resistance, expressed in ohms. First, we need to determine the current and resistance. To calculate the current, we first determine the total load on the circuit. The total load is calculated by multiplying the number of lights by the power consumed per light. In this case, that is 15 lights times 100 watts per light, equaling 1500 watts. The current is then calculated by dividing the total load by the voltage. Therefore, we have 1500 watts divided by 120 volts, which equals 12.5 amps. Next, we need to determine the total resistance of the wire. This can be calculated using the formula resistance equals resistivity times length divided by area. Here, resistivity is measured in ohm meters, length in meters, and the cross-sectional area in square meters. For number 12 American wire gauge copper wire at 75 degrees Celsius maximum ambient temperature, the resistivity is approximately 0.00001724 ohm meters and the cross-sectional area is 0.000000331 square meters. The total length of the wire is the distance from the source to the last light doubled, because the current has to travel to the fixture and return. This is calculated as 2 times the distance from the source to the last light, which is 150 feet. Therefore, the total length is 2 times 150 feet, which equals 300 feet. Converting feet to meters, we have 300 feet times 0.3048 meters per foot, resulting in 91.44 meters. Now, we can calculate the resistance using the previously mentioned formula. Resistance is calculated as 0.00001724 ohm meters times 91.44 meters divided by 0.000000331 square meters, which equals approximately 0.512 ohms. With the current and resistance calculated, we can now determine the voltage drop for each light using Ohm's law. The voltage drop is equal to current times resistance. This is 12.5 amps times 0.512 ohms, which equals 6.4 volts. Therefore, each light will experience a voltage drop of 6.4 volts. This voltage drop across each light is affected by the presence of other lights in the circuit. This is because the current flowing through each light is affected by the total load and the circuit. As the number of lights increases, the total load increases, which leads to higher current. The increased current results in a higher voltage drop across each light. Mathematically, this is represented by the fact that the voltage drop across each light is proportional to the total current flowing through the circuit. As the total current increases, the voltage drop across each light also increases.